Okay, today we're going to do the derivation for one of the simplest kinds of switch mode power supplies, the buck converter. Okay, all buck converter is we have a voltage source Vn in series with a MOSFET. We have a diode to provide freewheeling current for the inductor. We have an output filtering capacitor, and we have a load. This is our output voltage, and this is our voltage across our inductor. Okay, we're going to switch this up into two phases, an on phase and an off phase. First, we're going to solve for the buck converter during on phase, which means that this MOSFET right here is on. So when this MOSFET is on, this circuit looks like this. We have the capacitor right here, the load, V out, and VL. The current is flowing through the inductor from the MOSFET and not down to the diode. So the diode's not part of the on circuit. So if we do KVL around this loop, we have negative Vin plus VL plus V out equals 0. We do volt balance across the inductor so that VL is equal to Vin minus V out. This is one of our equations. Next, we're going to do the buck converter in the off cycle when the MOSFET is off. In that case, the circuit will look like this. Essentially, what is happening is the inductor VL is discharging out to the load. In this case, VL, if we do KVL around this loop, VL plus VO equals 0, or VL is equal to minus VL, V out. This is our second equation. So if we set up our waveforms, we have the on time, which is denoted by D. Then we have the off time, which is denoted by D prime. If we do the current across the inductor, we know that when it's on, the current is going through the inductor and it's charging up. Or in this case, the current's ramping up at a rate of what? VL is equal to Vn minus V out over L, the inductance. In the off phase, we have decreasing slope minus V out over L. So now we take these equations, we multiply them by the duty cycle in the respective times. We have D times Vn minus V out over L minus D prime. Sorry, let's put parentheses across this. V out over L equals 0. Now, we can eliminate the L's because they're common denominators. And so we can also move this over to the other side. We have dVn minus V out equals D prime V out. We can follow on through with some algebra. We can move this negative dV out to the other side. We can factor out a V out. We know that D prime is equal to 1 minus D, right? So then this is a minus D, that's a D. They can eliminate, leaves us as 1, which leaves us with dVn equals V out. Okay, some important things to note right here is the fact that this diode allows for the circulating current during the off phase, okay? The other thing to note is that this filter, some people call this a filter, right? So you want to make sure your switching frequency is way, way, way below the resonant frequency of this inductor. If not, you're going to have a bad day. You want it essentially to be in the passband. And that's about it. Thanks.